Hi all, and in this video I want to cover the topic of functions, how to create a function and how to call that function when you need it and not call it when you don't need it. So that's the whole idea behind functions. Functions perform a task that you don't always need. So when you need that function or when you need that particular task, you can call that function, execute it, return a value, or just perform an action. And then if you don't need that function, you don't have to call it. So what I've done already is I have created a new project in CCW, and I already installed the 850 simulator. I did not add any programs of any kind, so it's sitting here just an empty new project. What I thought we would do today is create a function that can be used to convert temperatures such as degrees C to degrees F or degrees F to degrees C. That seems to be something that a lot of programs require, and if I could create a function that will accept my input data and crank out my output data, but also a function that I could use in other programs with very little work and not having to reinvent the wheel. So we're going to create a function, and that function is going to perform two tasks. It's going to do the calculations for the temperature conversions, where C is going to equal, and that's centigrade, F, which is Fahrenheit, minus 32 times 5/9, and F is equal to C times 9/5 plus 32. So we're going to be executing these two equations, and we're going to be using a value called a unitless number. That's unitless. Meaning that the number that comes into this function might be in degrees C, it might be in degrees F. Not knowing what units it's in, we're going to call it unitless. And the output will tell me what that value is in degrees C or degrees F. As an example, let's say our input value coming into this function is going to be 100. Now that's unitless. I don't know if that's 100 degrees C or 100 degrees F. But coming out of the function, it'll tell me that if this is 100 degrees F, it's going to be 37.78 degrees C. If this is 100 degrees C, it's going to be 212 degrees F. So unitless number. Now before we start a function, we have to determine what is the input to our function and what is the output or outputs of our function. So if we look at this particular function, we could tell that the input to this function is going to be the unitless number. So I'm going to have an input to the function that is the unitless number. My output of this instruction is going to be either degrees C or degrees F. So I'm going to have two outputs. I'm going to have outputs of degrees C or degrees F. or I should say not or, but and degrees f. So anytime you start a function, you should always look at what does this function do, what is it, what do you want it to do, what are the inputs or input to this function, and what are the output or outputs of this function. So this is what we're going to create in CCW as a function. So let's go back to CCW, and we're going to create a user-defined function block. You'll see over in the project organizer, there's a user-defined function blocks, and there's a user-defined functions. The difference between these two are that user-defined function blocks can return more than one piece of data. A user-defined functions are functions which are for very simple operations where I only have to return one value or just perform something that doesn't even return a value. So since I have two outputs that I require from this function, I'm going to use the user-defined function blocks. So I'm going to create a new program under user-defined functions exactly the way I created it under programs. I'm going to right-click, say add, and I can choose the language that I want to use. Now I've got to be honest with you, normally I would write this particular program in structured text because it's just easier, but I'm going to use ladder because I can also demonstrate to you how the basic arithmetic instructions work in ladder. And that way I probably will not create a separate video just for math instructions because they're really straightforward as far as how they function and how they work. Now you'll see that it gave it a default name of FB1, but I would like to rename that. So I'm going to right click and say rename, and I'm going to call this temp converter. For temperature converter, and press enter. So that way I'll know what this function does. And then I'm going to double click on it to open the function. So I opened the program. Now something I have not showed you to this time is how to enter rung comments. You'll see this area when I hover my mouse over it, kind of outlines in blue. That's where rung comments can go. If you double click inside of that, you can start typing text. So I'm going to type in here, this rung will convert a unitless number to degrees, and we'll do C first. And the equation that we're going to use to do this is C is equal to F minus 32 times 5/9. So that's the equation we're going to use. And we're going to do this using just standard block style math instructions. So first thing we have to do is we have to do this subtraction. So we take a instruction block and we drag it to the rung and drop it on a target. And since I'm going to be doing a subtraction, I want to find the math instruction that is subtract. And here's the subtraction. I'm going to leave the enable on it. You don't actually need the enable for this, but I'll leave it there. And I'll say OK. You'll see that the enable, I'm just going to have running to the power rail anyway. And I'll see that I have two inputs here, I1 and I2. Well, I1 and I2, for those of you used to the Studio 5000, that would be the same as source A and source B. And the O1, or this O1 output, this is the output, which is equivalent to the destination in the Studio 5000. So what I want to do is I want to take my unitless number, which is going to be f, and subtract 32. So I'm going to need a tag or a variable for my unitless number. So let me double click on this field, and I'm going to create a tag called Unitless Number. Now I have to choose a data type. I know it's not bool because bool's either a 0 or a 1. I can select int, I can select dint, and not have any decimal points associated with it. However, this is temperature. I'd like to be a little bit more, not precise, but I'd like to display decimal points. So I'm going to use the real data type. I'm going to leave it in global scope. Actually, I'm going to leave it in global scope, and I'm going to leave local scope to this temp. So that's what I'm going to not do anything to these. And I'm going to say OK. So now I have a new variable called unitless number, and I'm going to subtract 32. So I'll click in the top field and I'll type 32. Press enter. Now here's something that we have to be concerned about, or we have to know, not concerned about, but we have to know. I've been harping about data types, and I have not covered data types in the CCW. CCW is very fussy about data types. And on an individual instruction, data types have to match. So if input 1 is real, input 2 has to be real, and output has to be real. If they're different data types, you will get an error, and it'll have to be fixed. Now 32, just the whole number, this program's not going to know whether that's an int, a dint. It's not going to know what type of data that is. Since I want this to be a real value, I have to change this to 32, and I have to add the decimal point, 0.0, and then press enter. That will make that a real value. So that'll perform the subtraction. Now I need some place to store that value, something temporary. So I'm just going to create a temporary variable. So I'll double click here, and I'm just going to say temporary 1, and I have to make that real. So now I have the difference between the unitless number minus 32. The next thing I'm going to do is I'm going to multiply by 5. So I'll bring another block down, I'll drop it on there, and I'm going to multiply. Same situation. Input 1, input 2, output 1. Source A, source B, destination. So I'm going to multiply the result from the subtraction, which is temp 1. So I'll click into the top. If I type a T, it takes me closer to where that is so I can select it. And I'll double click on temp 1. And what I want to do is multiply that by 5. So I'll click into the top, and it's real, so it's 5.0. Press enter. And I'm going to need another temporary tag. And I'm going to create another tag, and I'm going to call it temporary2, call it real. By the way, these temporary tags, you can call them anything you want. I'm just using the word temporary right now. The next thing I have to do is divide by 9. So I have to take this temporary 2 value and divide it by 9. So I'm going to come in, bring another block in. I'm going to use a divide. I'm going to divide temporary 2 by 9. And my output is going to be a new tag called degrees C. So I'm going to double click on the bottom and I'm going to say degrees C. And I have to make it a real. So that ladder rung will perform the conversion of a unitless number to degrees C, unless I made a mistake. Let's add another rung, and I'm going to do the same thing, but this time I'm going to do it to convert to degrees F. So in this particular rung, it's going to be this rung will convert a unitless number to degrees F. And I'm going to be using F is equal to C times 9/5 plus 32. So I'm going to build this the same way. I'm going to look at this and say, okay, I'm going to take unitless number times 9, so I need a multiplication. Oops, I missed it. No, multiplication. Multiply. I'm going to need my unitless number, so I'll click here, type U, unitless number, times 9, so I'll come in here and say 9.0. I'm going to create a temporary variable. So we're going to say temp3, make it real. Then I want to divide by 5. So I'm going to bring a divide in, or a block in, choose divide. And I want to take my temp3 variable and divide by 5. And I'm going to put this in another temporary variable. We'll call it temp4. Make it real. I don't know how that came in line there. We'll get rid of that. If you get any extra stuff, and I don't know why that happened, just delete it. You don't need it. And then I'm going to, let's see, I'm going to add 32. So I need an add instruction. And we'll find the add instruction, and we're going to take our temp variable, temp4, and we're going to add 32.0, and we're going to create a tag out here called degrees F, and we're going to make that real. Okay, so that created our program. I'm now going to open this local variables up because, and you could have done this at the same time where we were creating the tags, but we have to tell it what's called a direction. Now var means variable direction, but we have to tell it, is this an input or is this an output? Well, we already determined that our unitless number is an input. So I'll come over under the direction and drop this down and say input. We already know that degrees C and degrees F are outputs. So degrees C is an output and degrees F is an output. The others are just internal variables. We can leave them as variables. So this should do the job I want it to do. I'm going to now save this just so I don't lose that. All right, now we want to use this function. We want to be able to call this function within a program, because this program will not execute unless it is called. So those of you using or familiar with Studio 5000, you would have to use like a jump to subroutine instruction. But in this program, there are no jump to subroutines. So this code that we just wrote will not execute unless we call it. Let's show you how to do that. Let's come under Programs and let's create a new ladder program. So we'll right click, Add New Ladder. Let's give it a name. And we'll say using a function. Using functions. Again, you would call this program, give it a name that means something to what this actually does. And then I'm going to open this function this program by double clicking on it. Now I want to use this user-defined function that I called temp converter. If I take a box, an instruction block, and I drag it to this rung and drop it on a target, you're going to find that as you look through the list, that function, that user-defined function that we just created, is now part of the instruction block selector. And it says it's user-defined. There's my temp converter. So I can click on that, and I can even give it an instance name. I'm just going to leave it at what it is. So I can give it a variable name. In this case, an instance name. Because I can use this in my program as many times as I want, in different locations if I want. I'm going to leave the enable checked, because that'll give me an enable input on this instruction if I choose that I don't want to run it or not, or run it. So let's say OK. And there is our user-defined function. Notice Unitless Number is an input, degrees C is an output, degrees F is an output. That's what I called this function, and there is the instance name. All right, I'm going to now bring a contact into the enable, and I'm just going to call that, I don't know, perform conversion. I'm going to leave it bool. Now I need variables for these inputs and outputs. I can basically use the same variable names because the variables that I created in the function are in a different location. They're different than the variables I'm creating now. So let me double click on here, and I'm going to create a variable called Unitless Number. And press enter. And then I'm going to create two more variables. This one I'm going to call degrees C, and this one I'm going to call degrees F. And that's all I need to do. I can now run this program. This function will now only get called into action if this contact perform conversion is true. Otherwise, it won't call it. So let's download this program. Now, I did not set up my communication path, so we'll do that quickly. I should have probably done that before I started this. That's 106. Let's turn this on. Yeah. Okay. Come here. 106. Close. Okay. And then I'm going to download this program. And if I did not make any mistakes, it should download. We'll just give it a little bit of time to download. It did not have any errors, so let's download it. And we'll just give it a few minutes or seconds to download and get itself online. Yes, we do. Okay. Okay, here we are. Now, let me again close this bottom window just to get out of the way. Now in the Studio 5000 software, you could have just clicked in here to enter a value, but you can't do that. In this software, you could either do what I just did, double click, and it'll open up like a window table, or you can right click and say variable monitoring, and this will open up a variable monitoring table, and you can make this bigger or smaller depending on what your needs are. And then I'm going to come in here, and you can now put values in here. So I'm going to click in here, and I'm going to say I have a value of 100. So you see that value changed to 100. However, it didn't perform. Now, if you can see, if I try to click into the ladder, it won't let me because this window's open. But there's a checkbox here under logical value for perform conversion that I can check. That's the same as turning that on. And you can see that if 100 was in degrees C, I would have 212 degrees F. And if 100 is in degrees F, I would have 37.7778 degrees C. If this is 212 degrees F is 100 degrees C. 212 degrees C is 413.6 degrees F. So my function works. If I disable it and change this value, 32, nothing is going to happen because the function's not getting called. Now if I call the function updates. 32 degrees F is 0 degrees C. 32 degrees C is 89.6 degrees F. So that's how easy it is to create a function and then use that function in a program. All right, that's all I want to cover in this video except for one thing. And that is, let me disconnect. I want to go back offline, in other words. I'll close the simulator. Let's say I would like to use this function in another program. What I can do is I can export this function. So if I come onto the user-defined function block and say temp converter and say right click on it, I can choose export. Now I can export the program or I can just export the variables, but I want to export the program. So I'll say export the program. The export tab is already selected. There's also an import tab if I want to bring a function in from the outside that I've already saved, but I want to export. You can password protect it if you would like. I'm not going to do that. And it's going to export it as this particular name. And I'm going to say export. And then it's going to ask you, where would you like to export this? So you choose a path where you'd like to export it. And I'll just choose a path. Your path will be different naturally. I'll choose it here, and program code, and here. And I'm going to leave it just like it is and say save. I have now just exported that function. So if I want to import this, all I have to do is come up under device, do import exchange file, because I'm exchanging it. It's an exchange file. My import exchange file is now, the tab is now selected. I'll do a browse. I can select the micro or the file that I just created. I can say open, and it already knows that I have a function there by that name. Therefore, it's saying, do you want to replace this? If there was no function there, it would not have the replace, you can then import it. And I'm going to close this because it's already there. And when you come back, you'll have that function imported to your user-defined functions. So that's how easy it is to export and import individual functions. Now, I don't know if you've noticed this, if you've been following along with us, but when you create a project in CCW, and let me show you what's going on. If I create a project under program code, this is the project I'm working on, it creates a bunch of files and folders, as you can see over here. Well, if I had to have you send that to me, or if you had to send this project to somebody else, that's not a real good way to send it in all different kinds of files and folders. So what you can do is you can say File, Export Project. We'll export the project, and then you can choose where it is you would like to export it. So I'm going to choose a place to export it. And I don't know, I gotta see where I am here. Videos, okay. CCW, and yours, again, yours would be different. And let me create a folder here called Archive. And I'll double click there, and I'll give it a file name, and I'll call this Intro to Functions, and I'll say save. And it's been exported. It tells you that it's been exported. Now, if you need to send that to me or send that file to somebody else, when that file gets it, or when that person gets it, it'll just be one file. So if I look at this in my archive folder, it is now just one file. And when you receive that file, you would then say File, Import Project, and you can navigate to where it is, and you can import that project. And then open the project. That's how easy that is. Okay, so I know I went pretty fast because I was trying to keep this short. I'm somewhat long-winded, but I hope that helps. I'm going to have you do an exercise that's in the CCW help file, so that it shows you not only how to build another type of function, but then also has you use it in a program. So I'll let you know where that is in an assignment in Blackboard. Thanks a lot, guys, and I'll see you later.